Chapter 13, Calculations with Ratio and Percentage Strengths. We're going to skip over the pretest. Percentage and ratio strengths are two additional methods for indicating medication strength, the amount or concentration of active ingredient present in medications. When the solute or active ingredient is described as part of the total amount of preparation, the product may be labeled as percentage strength or ratio strength. Both express the amount of medication per unit of volume or weight of a total liquid or solid preparation. The labels indicate percentage strength, such as lidocaine 1%, or ratio strength, such as epinephrine 1 to 1,000. Many medications expressed in ratio or percentage strength also list the active ingredient amount, usually in the metric system on the label. As with all medications, consider the total volume or weight of medication in the container to determine the total amount of active ingredient. Ratio strengths are usually used for liquid medication with a very low concentration of active ingredients. Percentage strengths frequently express the amount of active ingredients in medications, the amount of solutes and pre-made intravenous solutions, and the strengths of various wound dressings and soaps. Percentage strength is always interpreted as an amount out of 100. It is used to describe various solutions and topically applied drugs. There are three basic types. So we have weight and volume, which is WV. It is expressed as X grams over 100 ml. This is read as X grams of active ingredient in 100 milliliters of total solution. For example, 10% calcium gluconate injection has 10 grams of calcium gluconate in 100 ml of total solution. And 5% dextrose in water, D5W, has 5 grams of dextrose in 100 ml of total solution. Normal saline, 0.9% sodium chloride, has 0.9 grams of sodium chloride in 100 ml of total solution. So just one thing to kind of remember, as we've talked about before, percentages are always out of 100. So that's where we're getting that 100 from, if you can just think of that in your mind. And you're changing the percent to grams for this one. So instead of 10%, it's 10 grams. Instead of 5%, it's 5 grams. Instead of 0.9%, it's 0.9 grams. And it's weight volume because there's grams on the top, which is a weight, and volume on the bottom, which is a liquid, milliliters. The next one is volume in volume, VV. And you can see that there's milliliters on top and milliliters on the bottom. So in these proportions, there will be milliliters on all of your sides. This is read as X milliliters of active ingredient and 100 milliliters of total solution. For example, 5% hydrogen peroxide solution has 5 ml of hydrogen peroxide in 100 ml of total solution. The next one is weight and weight, WW. So this one we have grams on top and grams on bottom as well. So we'd have grams on all four sides of our proportion. This is read as X grams of active ingredient and 100 grams of total preparation. So for example, 1% hydrocortisone cream has 1 gram of hydrocortisone and 100 grams of total cream. Working with the last two types may get confusing because both the active ingredient and total preparation have the same unit. So this just tells you a way to label them to help identify which one's which. And just remember, a percentage strength is always X out of 100 because percentages are always out of 100. Can never be more than 100%. I mean, there can be in some of our business math type problems, but for us, 100% is the highest. So we have this chart on abbreviations for common intravenous solutions. So knowing these abbreviations, just like knowing your SIG codes, are going to be very important because a lot of the problems are just going to assume that you know them and not give you the specific information. It might just say how many, of this in normal saline. It's not going to say 0.9% sodium chloride. And that is how it will be on the PTCB exam. So we have our abbreviation NS, of course, is 0.9% sodium chloride or normal saline. 1/2 of that normal saline is 0.45%, which is literally half of it. Then we have our dextrose in water. So whenever you see a D and then a W with a number in between, that is dextrose in water. We have dextrose 5% in lactated Ringer solution. We have a lactated Ringer solution or Ringer's lactate. And then we have dextrose 5% in 0.9% sodium chloride, which is normal saline. And we have that for 1/2 normal saline as well. All right, so the ingredients found in prepared IV fluids such as dextrose or sodium chloride are expressed in percentage strengths. These fluids are labeled with the percentage of solute found in the total solution. D5W or 5% dextrose in water indicates that 5% dextrose is based on 100, so the percentage is shown per 100 ml of solution, indicating that 5 grams of dextrose is found in 100 milliliters of fluid. However, if the solution is larger than 100 ml, the total weight of the solute must be calculated. And the easiest way to do that, of course, is to do a ratio and proportion problem. So in most cases, a physician will use common abbreviations for ordering IV fluids. These are shown in table 13.1 that we just went over. Dextrose solutions are always ordered as a percentage. However, the two most commonly prescribed sodium chloride solutions are sometimes referred to as normal saline, which is 0.9% sodium chloride with 0.9% NaCl, and a half normal saline, which is 0.45% sodium chloride. These solutions have 0.9 grams of sodium chloride and 0.45 grams of sodium chloride per 100 ml respectively. Always begin percentage strength calculations by identifying the known value. Whatever the percentage strength is, place a number over 100, then set up your unknown equivalent. And that is the easiest way to set up problems. So let's jump right into example 13.1. A physician orders 500 ml D5W for a patient. What is the weight in grams of dextrose in this bag of fluids? So we have this D5W, which means this is dextrose 5% in water. We're going to pull that out and we're going to use our formulas, which is gram per milliliter per percent. So we know that we're just going to put the 5 here and it's always going to be out of 100 when we're working with percents. So that is essentially the strength of that medication. We just want to know how many grams, what is the weight in grams. So when we're setting up a proportion, we know that we need, if we have grams and milliliters here, we need to have the same directly across from each other. So the weight in grams is what we're looking for. That's going to be our X. And we have 500 ml that we are providing. So we're going to go 100X is equal to 5 times 500. So then we're going to get out our calculator and do 5 times 500, which is 2,500. And we still have our 100x here. We want to get x alone, so we are going to divide each side by 100. So that crosses off and gives us nothing. And then we're just going to take our 2,500 and divide it by 100 into our calculator. And we get that x is equal to 25 grams. So if the strength of the medication is 5 grams per 100 ml, if we have a 500 ml IV bag, there's going to be 25 grams in that IV bag. Example 13.2, how many milligrams of sodium chloride are in 250 ml of normal saline, which is 0.9% sodium chloride? The known information is 0.9 grams of sodium chloride in 100 ml total solution. So we're taking out that 0.9% and we can rewrite it as 0.9 grams over 100 ml. And the question is asking us milligrams, and we have grams and milliliters here, but we will go ahead and just worry about that in a minute. So we're going to plug in that 250 ml. Sorry, that's 250. It looks kind of bad. And this is going to be our x, because we're looking for how many milligrams, so we need to convert from grams. So we have 100x is equal to 0.9 times 250. Now we're going to get out our calculator and do 0.9 times 250, which is 225. 100x is equal to 225. We want to get x alone. So we're going to do division by 100 on each side to get just x here. And here we will do 225 divided by 100, which gives us 2.25 grams. Now we need to convert that 2.25 grams to milligrams for our answer. So remember, our conversion factor of 1 gram is equal to 1,000 milligrams. And we are going to plug in 2.25 grams is x milligrams. So we have 1x is equal to 2.25 times 1,000. So 1x is just x, and then we'll just do the multiplication on our calculator. So 2.25 times 1,000, which gives us 2,250 milligrams. Example 13.3, a physician orders 500 ml of 5.5% Travasol amino acids to be used in a total parenteral nutrition bag. How many grams of amino acid will be provided? So of course we're going to take our 5.5% and we're going to just rewrite that as 5.5 grams over 100 ml. And we want to know, the question is asking us how many grams, so that's going to be our x. We need milliliters down here, and that is where we're going to plug in our 500 ml. So then we're going to do 100x is equal to 5.5 times 500. Get out our calculator. So 5.5 times 500 is 2750. So we still have 100x is equal to 2750. We want to get x alone, so we're going to get rid of that 100 on this side by dividing it by 100, which gives us 0. So we have x And then we're going to divide this side by 100. So 2750 divided by 100 gives us 27.5 grams of amino acid that we'll put in that IV bag. Percentages are also used for some liquid and semi-solid medications to show different strengths, such as 1% lidocaine. When interpreting percentage labels, the amount of medication is expressed as either weight per volume, solid in volume, such as 0.9% sodium chloride, weight per weight, solid in solid, such as 1% hydrocortisone cream, or volume per volume, liquid in liquid, such as 70% isopropyl alcohol, which is 70 ml of alcohol with enough sterile water to make 100 ml of total solution. And let's do example 13.4. Example 13.4. Interpret the following medication: 15% neomycin solution, weight volume. And if we interpret it, it's going to be this piece right here. 15 grams of neomycin and 100 ml of total solution. So that's what a percentage is just basically telling us. So we are going to rewrite it as 15% is equal to 15 grams over 100 ml. Now we want the strength in milligrams. So we need to use our 1 gram is equal to 1,000 milligrams, and we need to convert that 15 grams to milligrams. So placing into proportion with our units directly across from each other, this would be 1x is equal to 1,000 times 15. So this would just be x is equal to 1,000 times 15. Which gives us 15,000. So that's a 15,000 milligrams. So essentially the strength of the medication is 15,000 milligrams over 100 ml. However, this could lead to many mistakes with all the zeros. So we always express medications usually in their lowest strength. So we are going to take that 15,000 and we're going to divide it by 100. And that gives us 150. And that would be the same thing as if we took 100 and divided it by each side. That would leave us with just the ml down here, and that would leave us with 150. So our strength is 150 milligrams per milliliter. Example 13.5. How many grams of neomycin are in 200 mLs of 15% neomycin solution? So we're going to take that 15% and we're going to rewrite it as 15 grams over 100 ml. And we want to know how many grams, so X grams, are in 200 ml. And I've made sure that we have our units directly across from each other, and we would do 100x is equal to 15 times 200. Then we will get out our calculator. And do 15 times 200. We always want to make sure we're doing that multiplication side first. And that's 3,000. So then we have 100x. We want to get x alone. So we're going to divide each side by 100. So 3,000 divided by 100 Oops. 500 is 30. So the answer is 30 grams for that part. The next part asks how much neomycin powder is needed to make 50 ml of the 15% solution. So we're going to do exactly what we did in the first part and rewrite our 15% as 15 grams over 100 ml. But this time we're going to put 50 ml here, and we want to know how many grams that is. So we'll do 100x is equal to 15 times 50. 15 times 50, which is 750, and then we have 100x equals 750. We want to get x alone, so we're going to divide each side by 100. That crosses and cancels that out, and 750 divided by 100 is 7.5 grams. So we found out up here that we need 30 grams to make the 200 ml and only 7.5 to make the 50 ml solution. Example 13.6. A physician orders 3,000 ml of 15% neomycin solution to use for irrigation of a wound. The available medication is neomycin 0.5 gram tablets. How many grams of neomycin are needed to fulfill the order? So of course we're going to turn our 15% into 15 grams over 100 ml. We're trying to find out in this part how many grams are needed. So we know that's going to be our X, and we're trying to make 3,000 ml. We're going to look diagonally from our X and write 100x is equal to 15 times 3,000. Get out our calculator and do 15 times 3,000, which gives us 45,000. So we have 100x is equal to 45,000. Now you want to get x alone, so you're going to divide each side by 100 to get rid of that there. And 45,000 divided by 100 is 450. So we need 450 grams. The next part says how many tablets of neomycin are needed. So we know we need 450 grams. We need to know how many 0.5 gram tablets we need. So if we do our, on one side of our proportion, the known, we know that one tab is equal to 0.5 grams. And we want to provide the patient with 450 grams. How many tabs do we need? So we're going to do 0.5x is equal to 1 times 450. So 450, 1 times 450 is 450. And we have 0.5x. We want to get x alone, so we need to divide this side by 0.5. We have x. And then we also need to divide this side by 0.5. So we're going to do 450 divided by 0.5, which is going to give us 900 tabs needed. Example 13.7, what is the percentage strength of a solution containing 25 grams of active ingredient in 500 ml of total solution? So we are going to use the 25 grams over 100 ml, or I'm sorry, over 500 ml. And we know that percentages are out of 100, so we're going to place this over this side 100 ml, and then over here is going to be X grams. So we are going to do 500X is equal to 25 times 100. 25 times 100 is 2,500. So we have 500X is equal to 2,500. We want to get X alone, so we're going to divide each side by 500. Which is going to be 5. So we find out that the percentage strength is 5% because it is over 100. So that's 5 grams over 100 ml, which we know what we've been doing in all these examples. That is the same thing as 5%. Example 13.8 says how many ml of a 25% solution will provide 5 grams of active ingredient. So we're going to take our 25% and we're going to rewrite that as 25 grams over 100 ml. The question is asking how many ml, so we know that's where X is going to be. And then up here, our grams that we're going to plug in is 5. So we're going to go diagonally from the X right there. So that's 25X. And then that is equal to 100 times 5. 100 times 5 is 500. So we have 25X is equal to 500. We want to get X alone, so we're going to divide each side by 25, which leaves us with just X there. And in our calculator, we're going to do 500 divided by 25, which gives us that X is equal to 20. Example 13.9, how many milliliters of D50W should be administered to a hypoglycemic patient to provide 150 milligrams of dextrose? Think of this as how much 50% dextrose contains 150 milligrams. So of course we're going to take our 50% and we're going to rewrite that as 50 grams over 100 ml. But the problem is asking it has milliliters. So we need to convert somewhere. So we're just going to quickly convert our 50 grams to milligrams. So if 1 gram is equal to 1,000 milligrams, and we have 50 grams, how many milligrams is that? So that would be 1x would equal to 50 times 1,000. So we know that 1x is just x, so now we just need to do our multiplication. So we're going to get our calculator out and we are going to do 50 times 1,000, which is going to give us 50,000 milligrams. So now we're just going to erase that grams right there. And place our 50,000 milligrams. and we want to give the patient 150 milligrams. How many ml? So we're going to do 50,000 x is equal to 150 times 100. And our calculator, we're going to do 150 times 100, which gives us 15,000. And we have 50,000 x. We want to get x alone, so we're going to divide each side by 50,000. And then we're going to do 15,000 divided by 50,000, which gives us that x is equal to 0.3 ml. Now you could have done DA if you're comfortable with that. Of course, we're not going to show you that way. The book does. You could have converted at the end and still got the same answer. Example 1310, how many milliliters of 15% neomycin solution can be made from 150 grams of neomycin? So again, we're taking our 15% and we're rewriting it as 15 grams over 100 ml. We sure have done that a lot in this chapter. And we want to know how many milliliters. So you always want to pay attention to what they're asking. That's going to be our X. And we need to give the patient 150 grams. So on this side here, we have our known, which is 15 grams is equal to 100 ml. On this side here, we're trying to figure out how many ml to give for 150 grams. So we are going to do 15x is equal to 150 times 100. Which is 15,000. So we have 15x is equal to 15,000. We want to get x alone, so we're going to divide each side by 15. So 15,000 divided by 15 is 1,000 milliliters. The numerical amount of active ingredient in ratio strength is always 1. Ratio strength is expressed as 1x, with x representing the total amount of the product. It is frequently used to describe solutions with a very small amount of active ingredient. The three types are as follows. Weight, volume, which is expressed as 1 gram per x ml. This is read as 1 gram of active ingredient and x milliliters of total solution. For example, epinephrine, 1 to 1,000 is a 1 gram of epinephrine in 1,000 milliliters of total solution. 2, we have volume, which is expressed as 1 ml to x ml. This is read as 1 milliliter of active ingredient and x milliliters of total solution. For example, 1 to 115 sodium hypochlorite solution is 1 ml of sodium hypochlorite and 15 ml of total solution. The next one is weight, 1 gram to x gram. This is read as 1 gram of active ingredient and x grams of total preparation. So for example, a 1 to 500 hydrocortisone cream contains 1 gram of hydrocortisone and 500 grams of total product. Performing calculations with the last two types may be confusing because both the active ingredient and total preparations have the same unit. So we want to label them as follows to help identify the active ingredient measurement and the total preparation measurement. So you can do that if that helps. And let's do example 13.11. Example 13.11, interpret the following: 1 to 1,000 sodium bicarbonate solution. So that the interpretation is right here. That's 1 gram of sodium bicarbonate in each 1,000 ml of solution. So essentially this ratio is 1 gram over 1,000 ml. So we're going to use that on one side of a proportion. And remember that you can write these on either side. You get the same answer. I always just tend to write the known first. And we want to know how many grams are in 300 ml. So we would do 1000x is equal to 1 times 300. We know 1 times 300 is 300. And 1000x. To get x alone, we need to get rid of this 1,000 by dividing by it here, and then also dividing by it here. And then we take our calculator and we do 300 divided by 1,000, which gives us 0.3 grams. Example 1312. A physician orders 75 ml of a 1 to 15 sodium hypochlorite solution to be used in the office. How many grams of sodium hypochlorite are needed to prepare the solution? So we have our 1 to 15 solution, which means it's 1 gram over 15 ml. And we need to provide 75 ml. How many grams is that? So we would do 15x is equal to 1 times 75. So we have 15x is equal to 75. We want to get x alone, so we're going to divide each side by 15. And we're going to get that is 5 grams. Example 1313, how many milliliters of epinephrine 1 to 1,000 solution are needed to provide a 0.5 milligram IM dose? So remember that 1 to 1,000, that means 1 gram is equal to 1,000 milliliters. But our question does have us in milligrams. So just to quickly get rid of it, remember we know that 1 gram is equal to 1,000 milligrams. So I can easily just erase out this 1 gram and write 1,000 milligrams. And I want to know how much milliliters to give a 0.5 milligram dose. And so I would do 1000x is equal to 1000 times 0.5. So if I multiplied 1000 times 0.5, I am going to get 500. I want to get x alone, so I need to divide each side by 1,000. So I get x alone there, and 500 divided by 1,000 is 0.5. So I worked out that math, but just something you should know by definition. If on one side of a proportion you have the same two numbers, so here we have 1,000 and 1,000, then you know over here that you have to have the same two numbers. These proportions are essentially two fractions set up equal to each other. So if we had 1,000 and 1,000 on one side, we're going to have 0.5 and 0.5 on the other side. They would have to match. Example 13.14, what ratio strength is made by dissolving Benadryl 50 milligrams in a lotion to make 150 ml? So the first thing we need to do this ratio strength is we need to convert that 50 milligrams into grams. So we know, and then we want to convert 50 milligrams to grams. So we would just do 1000x is equal to 1 times 50, which we know is 50. So we have 1000x is equal to 50. To get x alone, we need to get rid of this number here, which is 1000. And then on the other side, we have to do the same. So 50 divided by 1000 is 0.05 grams. Now that's just the first part of this problem. So we're trying to find the ratio strength. So remember when we talked about those ratios, just before we started doing these examples, the different definition of ratios. So we have that one that's 1 gram over X. So we're going to place what we know on one side of our proportion like we always do. So 0.05 grams over the 150 ml. And we're going to use this on the here. So 1 gram is equal to X ml. So we would do 0.05 X is equal to 1 times 150. Which we know is 150. And we have 0.05 X. We want to get rid of that to have X alone. And we're going to do 150 divided by 0.05, which gives us 3000 ml. So essentially our ratio here, we got rid of all of our math stuff. It would be 1 gram to 3000 ml. And we know from all the other problems that that is the same thing as 1 to 3000. And that is the ratio strength. Changing from ratio to percentage strength, we're going to set up an R&T that asks the question, if there is one part of active ingredient in X total preparation, how many parts of active ingredient would be in 100 parts total preparation? And we'll do example 13.15. Example 13.15, what is the percentage strength of a 1 to 10,000 weight volume solution? So if there is 1 gram of active ingredient in 10,000 ml, how many grams would be in 100 ml? So we know, we just said it, 1 gram to 10,000 ml. So we'll just plug that in here. And then we are plugging in our 100 ml to find out how many grams are in 100 ml. So we have 10,000 X is equal to 1 times 100, which is 100. And then we have our 10,000 X still. We want to get X alone, so we need to divide each side by this 10,000. So we do 100 divided by 10,000, which is 0.01 grams. So that means there is 0.01 grams in 100 ml. And since it's 0.01 grams over 100 ml, that means the percent strength is 0.01%. What is the percentage strength of a 1 to 200 weight ointment? So this is the first time we're working with something other than weight and volume. If there is 1 gram of active ingredient in 200 grams total, how many grams would be in 100 grams? So we're essentially saying that this here is 1 gram over 200 grams. So I'm going to write that over here. And we want to know how many would be in 100 grams. And that's total solution. So total is always going to go on the bottom. And then we have X grams on top. So we have grams on all sides. But remember, the total amount is always going to be on the bottom. And the book has you write out all of these different abbreviations, if that helps. I don't think it does, but for me at least. 200x is equal to 1 times 100. 1 times 100 is 100. 200x is equal to 100. We want to get x alone. So 100 over 200 gives us 0.5 grams. So that means there is 0.5 grams in 100 grams of total ointment, which is the same thing as 0.5% since it's over 100. Example 13.17, what is the percentage strength of a 1 to 5,000 preparation? So we know 1 to 5,000 just means 1 gram over 5,000. We'll say ml, we don't really know, and that part doesn't matter. And to find out the percentage strength, we just need to multiply that by 100. So we're just going to get out our calculators. And we're going to do 1 divided by 5,000 times 100. And that gives us 0.02%. Example 13.18, what is the ratio strength of a 0.04% weight volume solution? So we know that 0.04% is going to just be rewritten as 0.04 grams over 100 ml. Now we're looking for ratio strength, so we're going to use those ratio definitions of 1 gram over X, which is XML in this case. So we have 0.04x is equal to 1 times 100, which is 100. So we have 0.04x is equal to 100. We want to get x alone. So now we're going to divide each side by 0.04. And we are going to do 100 divided by 0.04, which is 2,500. So that means there's 1 gram and 2,500 ml, which is the same thing as 1 to 2,500. So that is our ratio strength. In example 13.9 is done the exact same way. What is the ratio strength of a 0.01% weight volume solution? So we're going to take that 0.01%. We're going to rewrite it as 0.01 grams over 100 ml. And then we're going to use those ratio definitions. So we have 0.01x is equal to 1 times 100, which is 100. And then we have 0. We want to get x alone, so we're going to divide each side by 0.01. Sorry, that looks really bad. Zero 0.01. So 100 divided by 0.01 is going to give us 10,000, which means there is 1 gram in 10,000 ml, which means the percentage strength, or I'm sorry, which means the ratio strength is 1 to 10,000. Percentage and ratio strengths represent the amount of solute in a total amount of product. Percentage strengths depicts the amount of active ingredient in 100 pounds of total product. Ratio strength depicts 1 part of active ingredient in a total amount of product. Ratio strength is most commonly used for weak solution. Percentage is expressed using percent sign as an indication of the amount of active ingredient in a medication. The ratio is divided by a colon to separate the solute and the solution.